So I built a huge vapor blaster from 3 sheets of plywood and a couple 2x4s. Yes, it is waterproof, and yes, it is strong. Okay, so like I said, I built this thing completely from wood. Dude, you're crazy. This ain't gonna work. All right, dude, I know everyone's skeptical that I use wood, but it costs $4,000 less than a retail machine. Okay, so just give me a second to explain. So go sit down over there while I do. Whoa, that dude might have a point. Okay, reason number 1, which gave me this idea, is there are people building aquariums for fish out of plywood and using the same waterproofing products that I'm using to hold like 400 freaking gallons in their living room. And it doesn't leak a drop. The tanks don't blow out. The fish are happy. And the reason they're doing this is because an aquarium that large is like $4 grand, $6 grand, or whatever, and they're building it for a couple $100. So basically what they do is they build a box with a window in front and they just use one piece of glass, and it really reduces the cost. So if these guys can throw a tank in their living room, I can certainly have a cabinet in my garage where I'm just spritzing around a little bit of water. Okay, reason 2 why you should consider wood is because the expense of steel cabinets skyrockets once you get past the Harbor Freight size. So the Harbor Freight cabinet, if that size works for you, by all means go this route, because it is $200 for this cabinet and you're up and running, right? However, if you want something this large, all of a sudden a sandblast cabinet in this size costs about $1,000 to $2,000 depending on what you want. Then you got to go convert it to wet, okay? You're going to have to spend a couple $100. You're going to have to do a bunch of work and so forth. So you might as well just go this route. Plus, you're going to have to use sealant and some of the other products for waterproofing a steel cabinet as well. So you might as well just apply it to wood and be done with it. Also, I've been looking for a large used steel sandblast cabinet like on Craigslist or Facebook, and they're really hard to find. And even if they're 20, 30 years old, people are still asking like $800 for it. So this is the way to go, man. Okay, reason number 3, we are just spraying water in here, okay? And the design I have is there's a bucket under here. All the water runs down and is stored in this bucket when not in use. So what that means is if you leave the door open a little bit, this thing dries out in an hour or 2, kind of like the shower in your house. You take a shower, you know, all the walls are wet and whatnot, and 2 hours later it's all dry, right? Not a very demanding application as far as sealing is concerned and moisture problems, okay? So just rinse the cabinet down when you're done, leave the door open, and it's dry in a few hours. Okay, reason number 4. My parents have a 28-year-old wood deck, their summer home in Wisconsin. Okay, yeah, it's pressure treated. Yeah, there's probably some Thompson's water seal on there, but it's 28 years old, and no one shovels the snow off of it in the winter. It rains on it all the time. Yes, it's starting to show its age, but 28 years, and they have no plans on replacing it. We're gonna get a couple good years left of life out of it. Okay, reason number 7, and probably the most important reason of all, is that a machine this size, with all the features that I have, let's see here, they sent me a price sheet, retails for about $6,500. You want an immersion heater, add $375. Then you got tax and freight, you're looking at close to $7,500 for a machine, okay? And I don't think they have them in stock. I think it's built to order, so the lead time is, I don't know, 3, 4, 6 weeks or so. So during that time, you could save $4,000 and just build your own. Okay, reason number 8. There is no precision whatsoever in this cabinet build, okay? And here's what I mean by that. If the cabinet is out of square or slightly off from the dimensions I give, it doesn't matter, okay? And I goofed a little bit, okay? So for example, I cut all the wood. The back piece should have been 42 wide, and it was a 1/4 inch short or a 1/4 inch long, I can't remember. And the front piece was a 1/4 inch long or short or whatever. So when I put all the 4 pieces together, I was like, whoa, dude, this thing is way off, okay? And then at that point, you know, you could have recut all the wood. Or I said, you know what, who cares? So I built it, and I had to make a few adjustments to the frame and some other pieces. But you can't tell. The parts that you put in here, you can't tell, and it really doesn't matter, okay? Now, if you were to assemble an engine, and you're a couple thou off here or there, or you're off on the wrong torque or whatever, that is a huge deal when rebuilding an engine. Rebuilding an engine, you need to be 100% accurate, okay? Otherwise, you're gonna have a failure. With this guy, doesn't matter whatsoever. And also, plywood doesn't come perfectly straight. I mean, you actually see the dip in the top panel, but who cares, right? There's a little bit of a bow to the window. I mean, you can't have a crazy bow, but a slight bow is no problem because all these screws suck it back straight, okay? And then when you put the cabinet back together and you staple it all together, it seems to get a little straighter, actually. So again, zero precision. I was off on a bunch of parts. I actually snapped a drill bit in one location, like on one of these legs down below. And what I did is I just moved over a little bit and punched in a new hole, and it doesn't matter. I mean, you're not going to be able to see it. It's way in the back. So, and here's another thing. If you screw up any one single part on the cabinet build, it'll cost you $30 to get a new one. Let's say you screw up an entire sheet of plywood. You go out and get a new one, it's $30, okay? And there's a lot of scrap left over from the cuts, okay? And depending on what you need to redo, if you got to redo, you may have enough scrap available. I had to redo a 9x9 piece, and that was just an error on my part when I was doing the CAD modeling. And then I put it on the print, and I cut it exactly, but I needed to make it from this big to that big. No big deal. I had enough scrap to do that. Okay, also the level of difficulty. I'm going to rate it a 5 out of 10. And what I would rate a 10 out of a 10, again, is an engine rebuild. Like, for instance, the CB750 that I did, that engine took me 6 months to rebuild, okay? This thing took me about 2 months to build, okay? I mean, it's time consuming. Don't get me wrong. All this work, there's a lot of sealing involved, and there's a lot of jumping around as the sealant dries and stuff, but nothing's really terribly hard, okay? And like I said, if you screw something up, you can easily fix it or just keep going. I mean, it doesn't really matter. Okay, now I want to talk specifically about the products used inside to waterproof it, okay? Like I said, I went through like 4 or 5 caulk tubes of sealant, okay? And that's another thing. If you have a gap, even if you have a 1/4 inch gap on one of the seams, you're going to be putting sealant on it, and then you're going to be applying 8 to 9 coats of the rubber product that I used to form about a 1/16 to 1/8 inch membrane of rubber inside this machine. So yeah, that rubber is on there thick, okay? And you do 8 or 9 heavy coats, and it's rock solid, okay? Okay, now I want to talk about the limits of wood construction for vapor blasting, okay, and where it fails. So I have a piece of wood here that I did way before I even considered building this. I coated this wood with just a couple coats, and what I did is I started blasting the wood an inch away with the gun, which is a stupid test, but anyway, I did it. 30 psi, nothing. 40 psi, nothing. 50, 60 psi, didn't phase the product whatsoever. And 60 psi is a typical blasting pressure for aluminum, okay? But if I crank it up to 90, you're going to start to damage the walls of this wood cabinet, okay? If the gun's an inch away. Now, if you had a painted cabinet, you would start to remove the paint. After all, this can be used to remove coatings, powder coat, rust, all that stuff. So yeah, it will damage the walls if you go crazy an inch away at 90 psi at the walls, okay? So obviously that won't happen with a stainless cabinet, but stainless is even more money. Those cabinets are 8 to 10 grand, okay? Okay, so you're probably thinking, well, I remove coatings, I need high pressures or whatever. So here's a way around this that I may come out in the future. You got to hang rubber liners inside, okay? And that would be pretty easy to do. We could poke studs through, seal them all up, and then you just hang your rubber mats up against the wall, so when you're blasting and the media hits, it'll deaden the blow, okay? Also, let's say you had a sharp metal part, or you got too close with the gun at a high pressure and you damaged the wall a little bit. Well, after you're done blasting and the thing dries, you can go back and touch it up with the product, okay? They sell touch-up paint for cars, and consider having a little bit of touch-up work to do every year or two as you use this thing, okay? Okay, one more thing. If you apply 90 PSI to the system and you take the blast gun and aim it at the window, you will also etch the glass, okay? And I've done that before. I was messing around out here with the kids and we were blasting. I had some aggressive media in there and I tried to fake splash them. I etched the glass. Whoops. So you can't do that. So guys, the point I'm trying to make here, there are obviously some compromises with wood construction, okay? I'm not here to BS you on, hey, this is the greatest thing ever. No, because I'd rather have a plastic cabinet. I'd rather have a stainless cabinet, but I don't want to pay for it. And maybe you don't either, okay? And it's kind of like one of those things, like if you pinch yourself really hard, it's going to hurt, right? Well, there's certain things you can't do with this thing, okay? But generally blasting at 60 PSI, no issues. And that's where 95% of blasting happens, okay? And also, you can destroy parts with this machine if you want to, okay? This thing can be gentle or you can destroy things. Just like anything in life. There are tools that you can fix things or you can really mess stuff up, right? So that's all I'm trying to say here. Okay, another reason. Sometimes in life, you don't need the best thing to achieve a certain result, okay? Let me make an example with my dirt bike here. So this is an '01 dirt bike, and I go to the motocross tracks with it, and it's like $1,500. That's the value of this thing. And I go to these tracks, and I see people with brand new $50,000 trucks, brand new $8,000 dirt bikes, all the gear, and they're out riding. Some of these guys are really fast, and then some of them are total beginners, okay? And that's fine. The end result is everyone's out there having fun. And this thing can still kind of hang with some of these new bikes, okay? Would I rather have a new bike? Yes. Would I like to have a brand new truck? Yes. But, you know, I'm having just as much fun out there with a guy with a brand new bike, and sometimes I'm even faster than these guys, okay? And some of them, they're killing me. I'm not even that good of a rider. But anyway, my point is, you don't have to spend a lot of money sometimes to get an end result. And what I love seeing people do is instead of just buying something to fix your problem, use your hands to build or fix something. You know, I went through this whole thing and rebuilt it all. And, you know, it's just, I like living my life that way is what I'm saying, okay? So, you know, maybe you could just build something. Okay, one last benefit of using wood, it is scalable. Now the size you see here is 42 by 30 because that's what works in my garage in that one space. Okay, that was the maximum size I can go. But imagine building a much bigger one for, you know, roughly the same money as this one cost, okay? Because wood is cheap. Wood is the part that's getting larger and a little bit more ceiling. But in any case, scaling this would be super easy. So maybe in the future, if there's enough demand, we can probably all agree on the next size to build. And that's something I probably wouldn't keep. I would just build it for you guys and, you know, come up with the plans and whatnot. But yeah, that's later on, okay? But I just want to make note that wood is scalable. Now, if you get these plans, you have to build this size because otherwise the funnel angles go out the window, okay? All those bevel cuts and those angles, it's specific to this size here. Okay, so how much did it cost me to build this guy? Well, it cost about $3,000, okay? Now, a couple things. I didn't really shop around for the best price for any of these parts, okay? If I were to do that, I could drop the price a little bit. Also, if you don't need all this fancy stuff, no control box, no wiper, no precision regulator, no closed loop, you can probably get the cost down to $2,000 or less, okay? Also, I bought a lot of stuff in bulk, so I have a ton of leftover stuff, like airline tubing. I think I used 20 feet of it. Well, I bought a $100 roll, and it was really expensive. So if you shop around to get places that sell it by the foot or maybe a smaller roll, but for me, I stuck to 11 stores and bought whatever I could. It was during COVID, so I went after convenience rather than a dollar amount. Okay, so let's talk about how this machine works, okay? It's plugged into the wall. What you do is you turn it on, okay? At that point, the lights come on, okay? You can load your part up and start blasting, or even this is the closed loop version. So what I have here is an on-demand pump, okay? You can rinse all day long if you want, okay? Because it just recirculates. And notice I am spraying the window right now, just directly at it, and I have 0 leaks around the window. So that's awesome. Okay, so you can load your part in. Here's the gun. At that point, you can start blasting. So what I have here is a foot pedal, and you just press it, and it'll start blasting. Now, this thing is fully automated, so once you hit the foot pedal, a couple things happen. The air starts going, the slurry pump fires up, and so does the wiper motor. And so does the window rinse. Okay, so that all happens all at once. So here we go. So the wiper motor has an off feature. We got low, and we got high. And then up here I have an adjustable valve to spray however much water you want on the glass, okay? By the way, right now the air is turned off for the blasting, so I can crank that up. So that's 30 PSI and it's blasting, okay? I'm gonna turn that off so I can talk. So anyway, I just like a little trickle on the window. You can get all sorts of nozzles and stuff if you want to get all fancy. You can turn the water off if you want, okay? I like to leave the wiper on low, and then I usually do something like that. And it just lubricates the wiper, the media gets cleared, and everything's cool. Okay, so after you're done blasting, here's what happens, okay? And this is the automated closed loop feature, okay? So what happens is I got an overflow valve on this bucket, and that's how all vapor blasters work. Whatever contains the media in the water, that level of water is going to rise because you're adding water for the rinse and from the window. So at some point, you're going to have to purge that water out because it's diluting your slurry, and also whatever container it's in is just going to start to get full, okay? Problem is, you don't want to open that valve right away after you're done blasting because all the media is suspended, okay? So you want to wait a minute or two and then open it, okay? Let that media settle out, okay? So what I have here is an air-operated valve, and it's hooked up to a time delay, okay? And it's a programmable time delay. Okay, so you can set that time delay to whatever, and after that goes off, you're going to see the water puke out, and most of the media has dropped out, okay? And then it goes back in these closed loop bins. It filters out any remaining media, and this big bin down here is a reservoir for the on-demand pump, which supplies your rinse in your window, okay? And that closed loop, so that's the closed loop. The water basically ends up back at the start, and it goes through the system again, and it just keeps recirculating, okay? So that's nice if you're in a garage and you don't have water hookup, so this is the way to go. It's definitely more expensive to build, but I really prefer closed loop, to be honest with you. There you go. You just heard that air exhaust, and water's coming out of that valve. It's puking out any water. There's barely any media in it. And another nice cool thing is if I were to hit the foot pedal again, it would cancel that output and close that valve. So watch this. So there you go. I just tapped it and it closed the valve, and it goes into another time delay cycle. Okay, so some other cool features that this blaster has. It has a precision regulator, just like the retail machines. You have the adjustable window rinse like I mentioned. This is a heavy duty wiper motor over here. It's 2 speeds. This is, you can use it in marine applications. So for this, it's great because it's wet, right? We have a fully automated control box, which is super easy to wire up. Got an hour meter on here in case you want to track how long media lasts and stuff. These gloves here are rubber. They are seamless and they don't leak at all. Also, all of the plumbing is high flow on this. This guy, without the gun installed, will flow 45 CFM at 60 PSI. So that's what I built all the fittings to flow that amount. So if you have a crazy big compressor, you can run high CFMs in this thing. Okay, so I've made plans so you too can build one of these. The plans are available for purchase by clicking in the upper right. And guys, if you decide to buy these plans and you start going through this and you go, whoa, this is too much for me, I'm not able to do it, or too much work, or whatever your reason may be, just ask me for a refund. At the end of the day, I want you to build one of these. I want you to save money. And if I can't do that, then I'll just refund you. And maybe you should be going to buy a $7,500 machine. Maybe that's easier for you, and that's fine. Okay, so let me talk about the plans for a little bit. All the videos totaled, it's 13 hours long of video content on how to build that guy. It goes step by step, very detailed. Every wire is shown how it gets hooked up. And yes, I still fast forward through things like when I'm running in 100 screws. You know, you'll see me put 1 or 2 in, and then I fast forward through stuff, and it's still 13 hours long. It's crazy. So yeah, it's crazy long. And it's divided into 35 chapters to divide up the work for relevant areas, okay? Also, what you get is over 20 PDFs. So things like 2D drawings that I generated from my CAD system. You get parts lists with links. So you just, let's say you need a solenoid. You go over, you click on the link, and it brings you to the website to where you can just add it to your cart and buy it, and they'll ship it to your house, okay? Like I mentioned earlier, there's 11 stores that I bought everything from. Other things that are included is an electrical schematic, a pneumatic schematic, and also I give you templates. So for instance, you need to punch a hole that big for the gloves. Well, I give you a print. There's a circle on there that's the correct diameter. You cut it out and you just lay it on the piece of wood, trace it, and then use a jigsaw to cut it out. Okay, I also have a couple of video chapters and documents on custom gun info. In here, I have the Tacoma gun, which I highly recommend, but if you're looking to just spend $20 or $30 on a gun, I have a bunch of recipes and modifications so you can set it up to consume any CFM that you want. Okay, something else that this machine has is an immersion heater. And an immersion heater just simply heats the water. And that is useful for light degreasing. This machine should not be used for degreasing, but it's for wintertime. I heat my garage at 45 degrees in the winter, and when you come out here and blast, that cold will go right through the gloves. So just heating the water to 80, 90 degrees takes the edge off, okay? And actually keeps you kind of warm in a cold garage. And then going higher, obviously, for degreasing issues if you're into that. Okay, plans also include 230 volt information for people outside the US. Now, if you're outside the US, I put together a little video for you guys, so go ahead and click here. You can get into the plans, and I got like a 6-minute video that you can watch that goes over some challenges that you're gonna have building this, okay? Because not everyone I used ships outside the US. However, I know that you can find an alternative part wherever you live because people have been doing it with the Harbor Freight build, okay? But I just wanna be upfront with that. And also it discusses the few components you need in order to go from 120 to 230 volt. Okay, after you buy the plans, you instantly get emailed access to what you see here. And this is all the content. Like I mentioned, there's 35 video chapters, and then there's like 20 plus PDF documents. There's 55 different things here. And the videos you simply just click on and watch. So here you go. Here's a video of me cutting the piano hinge, installing the door seal and whatnot. Okay, so there's a bunch of video chapters, all right? And then down here you can download PDFs. Okay, so over here is a PDF that you can just click on download. Okay, so I just opened up one of the prints. So this is a 4x8 sheet of plywood, And you can see I got ordinate dimensions, so you can easily lay out all the pieces and they stack nice. You make one saw cut for 2 pieces, if you know what I mean. And man, these dimensions are really clear on here. They're CAD generated, so they're exact per the model. If you cut per this, it's going to fit together great. So there's like 20 to 25 prints, okay? Actually, there's 18 prints. The rest are schematics and stuff, but that's what it is. So you can print that out, and I'll show you a printed out version as well. Yeah, so there's a ton of info in here. I think you guys will really enjoy this. Okay, so here's a print that I printed off on a printer. It's hard for this to show up on camera, but anyway, they're all nice prints. Here's a parts list, so you get a description, quantity, manufacturer part number if it applies, vendor part number if it applies, cost each, cost total, and then here is a hyperlink. So when in the PDF document, you open this guy up, you click on this link, and boom, it launches up, you know, a store that you need to go to and buy it. For instance, this is a list, and I listed it per vendor. So for instance, all these parts under here, Home Depot or any other big box store that's going to be local to you. Yes, you can buy it online, but these parts make sense just to go to a store and buy it. Covered the print, and then also I give you prints for templates. So this will be on an 8.5 by 11 sheet of paper. Cut it out, and this is your 7.5 inch hole that you need to punch out for the glove ports. Okay, here's a 4 inch for the drain. So I give you all these because hole saws for this size is very expensive. So what you do is you drill a hole and then you just use a jigsaw. All right, let's see what we can fit in here. So this is a 26 inch diameter tire that I just had laying in back. So imagine if this was a whole wheel and you wanted to blast it. It fits right in here, no problem. Okay, you're probably wondering how strong this thing is. So I have done some real scientific testing on that. So here it goes. Okay, so you saw me crawl in and out of this machine. I am 5'10", 170 pounds. The thing didn't even flinch, okay? I don't know how much this thing can honestly hold. I strengthened the hell out of this cabinet, okay? When you see the plans, you'll see that I used some good strengthening techniques. But anyway, I don't see more than 170 pounds going in here, to be honest. I mean, people want to put engines in here. I think engines should be disassembled to be put in here. And then at that point, cases, cylinder heads, and stuff like that, they don't weigh 170 pounds. I mean, lifting 175 pounds in here, 170 pounds in here, I mean, that's a lot. I think it's perfectly strong. Okay, another cool thing that I did with all this is I tried to make this machine as compact as possible in width and depth, okay? So let's say you look at the retail machines, the closed bins are on the outside and they're hanging way out. Okay, so you obviously lose space when that happens. Well, I was able to shove them underneath the machine along with the bucket of slurry, right? So that's awesome. Another thing is a lot of machines have the vent hanging out the back. Okay, look at this elbow. You're losing 6 inches from the wall to the machine of dead space. Okay, so I put it on the top. I can put this machine right up against the wall and my vent is still functional. Okay, so that's an awesome spot for it. Another thing is they have the control box on the side. Okay, so imagine another 6 to 8 inches of control box hanging off the side. You never go in the control box. I mean, there's a timer in there. You can mess with it, program it. So that's why I stuck it up on the top. That is something that you're never going to really bother with after you build it. And that's just empty space right there. Okay, another thing I did is found plastic perforated sheet, cut it to size, and that is the platform inside here, which works great. And then over here we have a pull ring. You just yank that guy up, and then this thing can slide up and be stored on the back wall. So in case you ever had to service any of the plumbing work underneath here, you can do so. Also, since this is not a hopper drained machine, or it's not a hopper-based machine, the water level is not underneath here, okay? Imagine if you were blasting a small part and you drop it down and it falls into the water where the pump and the slurry is. That will be a pain in the butt to fish out. So what I have down there is a strainer. The part will fall, the strainer will catch it, and it's really easy to retrieve. So there's no way it'll fall down into the tub there. Okay, I also built a drip tray, and this is 100% made out of wood and waterproofed. Okay, so what I'll do is I'll hit the door with some water, and then we'll open it. Okay, so right now I'm spraying the door. And I think I had a dropper water leak out of here during my water test, so let's see. Actually, no water leaked out of it yet. Let's see. Yeah, there's no water. Okay, but what you do is you pop this a little bit, and you'll see that, you know, the water runs down the door. Okay, so when you get to this point, you can knock it a little bit to get the water off, right? And then you can open it up. Okay, and then also back here I have a drain which leads right back to the pit. Okay, so you can come over here, and once you get media in here, you just go like this. And you clean this all out. So that's freaking awesome. You can't sit on this wood tray, okay? It'll probably break. So that's the limit of that guy. It's meant just to hold and rinse down a little bit of water. Okay, another nice feature I added to this machine is the Tacoma blast gun. This gun here costs about $170. They also have a $120 version, but in any case, this is what retail machines come with. This is the gun I originally used. This is a $10, $20, $30, $40 gun, depending on where you buy it. And I've done extensive testing with these two. And if you set up both to consume the same amount of CFM, so in this case, this guy consumes 16, 17 CFM at 60 PSI. That's 5-horse compressor range. If you set this gun for the same, this thing is 2 times faster in processing parts. Okay, so having said that, I'm willing to bet if I were to race a retail machine, assuming same CFM consumption, this machine would be 2 times faster because I know what this gun can do, and I also know what that gun can do. Now, if you want to spend $30, this gun works perfectly fine, but if you want to go 2 times faster, then I recommend you buy this one. Now think about that for a second. You're spending $100 to $200 for a nice gun, but think of how much CFM or how much more horsepower you would need compressor-wise for these two guns to be equivalent. I mean, that price is thousands of dollars, okay? Compressors are not cheap. So you want to be as efficient as possible. And basically, the difference between these guns is the quality of machine work. That's all better flow. And then they have a different nozzle design that essentially speeds up the media at a lower, while consuming less air, okay? So it's all physics, okay, on how this thing can accelerate the media to a certain speed and process the parts faster. That's all it is. So it's basic physics on flow. And I studied aerospace engineering in school, and we went over nozzle designs for rockets and stuff like that. So I completely understand how this works, and this makes total sense, okay? Okay, I talked about this plastic tub earlier, but I want to cover the advantages of all of this down here, okay, of the pit, of the bucket, okay? So first of all, it's plastic, right? And that's where all the water sits when it's stored. Another advantage is there's water, media, and a pump in here, and that all weighs about 200 pounds, okay? So that means I have taken 200 pounds out of the machine, so the machine or the cabinet doesn't have to be as strong, and it lives down here, okay? So my legs can be skinnier, my funnel doesn't have to be as strong, and so forth. Okay, another advantage is that I feel that the bucket will have a quicker media change process, okay? Imagine if this was in the hopper, okay? You need to flow water at the media to get it to flow out of the machine, okay? With this guy here, I drain all the water and then I use a scoop. a drywall mud scoop, and I just scoop it out, probably 10 scoops or so, and most of the media is out. I mean, it's similar to being at the beach when you were a kid and you're playing right at the water level where the sand is really wet. I mean, the water doesn't flow it very well, and it's very heavy, and it's hard to move it, right? You remember that as a kid. So I think media changes are way easier in this setup over a hopper. Okay, another advantage is, imagine if you had two different pits with two different medias. Okay, let's say you have a really nasty part and you got to do a coarse pass and a fine pass, media-wise. You have your coarse media in here or in there or whatever, and after you're done, you rinse it down and you do a swapperoo with the pits. Okay, you could load it with another pump or just swap pumps, and I think that would be awesome because a lot of us don't have room for two cabinets, so swapping of pits would be a really good idea. All right, so let me disconnect everything. And I got some plugs here, so you can plug what you just took apart. Okay. Try not to spill water everywhere. Okay, so that's out of the way. Okay, next up we can unplug it. Okay, and that guy rolls out and you can do whatever you want with it. Okay, I want to talk about sealing for a second. First of all, whether you guys know this or not, but I'm a mechanical engineer, and that's actually my full-time job. I've been one for 15 years now. And I've actually worked at two different companies where one company they made windows for transit buses, okay? And then the other one was we made bus doors. The doors that open and let passengers in, okay? So I came across a lot of sealing projects, okay? And I will tell you that bus windows and bus doors, all the stuff I had to design, was way harder to seal than this application. So let me explain. This is the easiest thing to seal in the world because it is a flat plane, okay? And wood is pretty flat as well, so you just have one seal, one tier of sealing, and it's fine. Same thing with the window. This thing was bowed about 3/16 of an inch, but you know, I used the correct foam back there for the right compression, and bam, no sealing, no leaks whatsoever. Okay, so no leaks whatsoever. I mean, this is a super easy thing to seal up, okay? Okay, guys, I want to talk about like certain parts that I didn't spend any money on and parts that I really spent a lot of money on because, you know, what I felt was important. So, for example, obviously I didn't spend a lot on the cabinet. It's made out of wood, right? It's going to work just fine. I didn't spend a lot on the casters because I don't plan on moving this thing around. So these casters are a couple bucks from Harbor Freight. What I thought was important were things like the automation. I like the automation aspect of it, so I spent a lot of money on that. I think a wiper is important, so I spent a lot of money on that. The regulator, yes, that's important, so you spend some money there. The blast gun was expensive. The plastic perforated sheet, you know, I think that thing was like 150 bucks. I spent way too much. I could have shopped around and got it for like 90. But anyway, I got a good slurry pump and so forth. So you could give and take with all this. I mean, if casters are really important for you, go spend more on casters. Okay, something else I wanted to spend my money on is these 3 light bars. About 100 bucks worth of light because I like a lot of light. These are waterproof. They have a 5-year warranty, and the output of these 3 combined is like 1100 or 1200 lumens. So it's definitely bright in here. Okay, I want to talk about these 2 machines and how they differ. Okay, first off, I built the Harbor Freight 2 years ago, and it's been rock solid with the exception of my old wiper motor. This is the new heavy duty wiper motor that I upgraded to, and it's been working perfect. So that's the only thing that's failed on me in 2 years, okay? Now, in terms of functionality, both these machines are identical as far as theory is concerned, okay? But I kind of went with some different parts on this machine. So let me explain. On the Harbor Freight, I went with a pneumatic foot pedal. With this guy here, I went with an electric foot pedal, and what that does is it kind of simplifies the control box, it reduces some cost, and it also gives you some flexibility in terms of length of, placement of the foot pedal and whatnot. So it's just simpler, okay? Another thing is with the Harbor Freight build, I used mostly brass fittings. Here I use 100% plastic because I think they are just fine and they are much cheaper, okay? And then with the Harbor Freight, I used all screw-in pneumatic fittings. I mean, these fittings you screw in, but it's all push-to-connect hoses on this machine, and that's just simpler. It's a little more money, but I think, in terms of assembly and building it, super easy, and it's really flexible on how you can route everything. Okay, the Harbor Freight has 2 control boxes because I went with open loop, and then I decided I want closed loop. Here I just went with a big box right off the bat. Everything fits in there. Okay, let's go over some dimensions. The Harbor Freight cabinet is roughly 34 inches wide, okay? The Wood Blaster is roughly close to 45 inches wide because of the drip tray. And the internal width is 40.5. The Harbor Freight cabinet is 22 inches deep. This guy here is roughly 30 inches deep, and the internal dimension is 28.5. Okay, so a lot deeper and a lot wider. Okay, in terms of internal working height, the Harbor Freight cabinet is like 16 inches, and it's kind of hard for me to give you a dimension because it's an angled surface, okay? But this guy here has a 28-inch working height, and it's much bigger because only this surface is angled and the flattest top, so you can fit a lot more stuff in this guy here. Okay, in terms of height, this guy, the Wood Blaster, is 76, 77 inches tall, okay? Okay, as far as the door opening, what we have here is roughly 24 inches that way, and then this way, about 25, 24 inches that way. So yeah, it's a big door. You can fit a lot of big things in here. Okay, what's cool about building your own is you kind of customize it. So for example, take this spot, for example. This guy is pulled away from the wall a little bit, but you can see that I didn't want a door on the right because I got a cabinet there. So that's why I put the door on the left. Also, I'm a lefty. I hold the gun with my left hand, so all the blasting goes that way, and that is way more sealed than a door, right? So that worked out in my situation. Also, I only had like 45 inches of width to slide this guy right in this spot in my garage, and it just happens to be a nice big size, right? Also, I have a shelf there, so 76, 77 inches tall, worked out for me, and it just happens to be a nice height as well. Now, if you decide to buy these plans and you build this cabinet, all you have to do, if you want the door on the right, all you have to do is take these 2 components and assemble it on that side. Or you could even build 2 doors if you want, okay? If you want, you can put the control box on that side. I'm a lefty, like I said, and I'm going to be holding the gun in my left hand, and if I want to adjust pressure, I do it with my right hand. So I'm a lefty, and I built it that way. You can flip-flop any of these parts anywhere you want. I mean, if you mirror everything across the center, you can just swap everything left to right. No big deal there. Okay, so what should you do with the $4,000 that you save? Well, I would recommend going buying a really good compressor, okay? And I want to talk about compressors for a second. This machine, or any blasting machine in the world, whether dry or wet, requires air, right? The more air you have, CFM-wise, the better it's going to work, okay? It's as simple as that. That is what's doing the work. And in order to do work, you need power, okay? So it's all about horsepower, okay? And a good analogy would be You don't take a 3 horsepower mini bike to the quarter-mile drag strip and expect to run a good time, okay? So what do? You add horsepower, right? That's what people do for drag racing. I mean, yeah, assuming you can put the power to the ground with the chassis and all that, but if you can put more horsepower into the car, then generally you will get a better or faster time in the quarter mile, right? Same thing applies here. If you have more CFM, more horsepower in your compressor, then it reduces the amount of time to blast parts, okay? And you got to size your gun per the compressor, okay? And I explain all that in the plans. And I've built 10 different gun recipes ranging from 6 to 25 CFM of consumption. I went down to 6 CFM, and I got videos on this on my YouTube channel. I went down to 6 CFM just to see if you can do it, and it will vapor blast at 6 CFM. Would I recommend it? No, it'll take forever, and you know, I just don't have the patience for it, and I don't think you're going to be very impressed at that CFM, okay? 10 CFM, yeah, it works okay. I'm currently at 16, 17 CFM with the Tacoma gun, and it works excellent, okay? I've also tried 25 CFM, and it's like a freaking fire hose. It works way faster than at 16, 17 CFM. So I currently have a 5 horsepower, 2-stage compressor. It's 19 CFM at 90 PSI, and it works pretty good. I would love to go to 7.5 horse, but you know, they're expensive, and maybe in the future. But anyway, what I would really recommend is you can get an 18 CFM 5 horse compressor for about $1,000, okay? So that's a really good starting point, okay? And of course you can go less, but just don't expect quick results, okay? It's simple as that. So in the plans, I will further discuss recommended compressors and stuff like that, okay? But basically, I hope you get the idea. I mean, more CFM is better. And it doesn't matter on your tank size, okay? You will drain a tank in a minute or two. It's the pump to keep up with the constant air that is needed for one of these, okay? It's the pump that needs to keep pushing air to the machine, okay? That's what you really need to look at. Okay, guys, I got an aluminum transmission case here. I'm going to demo the machine, and we're just going to duct tape off a small section. I will blast just this, okay? This part here was sitting on the ground. There, see all this white stuff? This is corrosion. This is really difficult to remove, actually, and what I have in the machine loaded right now is fine glass bead. It's actually the wrong media to use on this. I would use something a little coarser to cut all this stuff off, and then I would swap media to the fine glass bead. But you know what? Just for purposes of demonstrating how this machine works, is I'll just do this little area, because this area doesn't seem all that bad. It's just dusty. All right, so maybe in a later video I will completely do this part, but it's going to take a media swap, and it's probably going to take at least 2 hours. So I just want to do a quick area and show you how this works.